Hello and welcome. Eamonn Darcy is my name. I'm the founder and director of Qbism, the Quantum Education Centre of West Australia. And welcome to the video lesson 3 on the interpretations of quantum mechanics. So we have done thousands of experiments. They all give the same results. But what is actually going on? And there are various interpretations which quantum physics is basically based on. So let me get my 10 minutes ready. So 10 minutes starts now. So let's get straight into it. What is an interpretation, basically? Because it's important to remember that these are interpretations. And what actually happens in quantum physics defies all logic that we've ever known, and everything's counterintuitive. So we cannot expect an intuitive or a logical explanation to explain these things. There are 4 main interpretations, and I'll go through each of them. The Copenhagen Interpretation, the many worlds interpretation by Hugh Everett, the pilot wave, which is De Broglie, and Qbism, which has become very popular later. So let's look at each one of these individually. I have 8 minutes 40 left. The Copenhagen. Now, the important thing is that the Copenhagen is probabilistic. It says that fundamentally our universe is probabilistic. If you remember, going back to video lesson 1, when we were talking about the double slit, and that when you had the camera there, when you measured it or observed it, neither of these are the right words, but when you had the camera there and tried to measure it, the wave function collapsed. The superposition was no longer. It became a definite particle. It is quantized. It is in a definite location with a definite momentum. So what is actually happening, though? What the Copenhagen interpretation, mostly by Bohr and Schrödinger, the 2 people you see there, Bohr's on the right, Schrödinger's on the left, and they said that when you measure it, it collapses, and it collapses to 2 separate, the highest and lowest, what we call Eigen Values, which in a quantum computer system is 1 and 0. And it is completely random. So it will go to 0 50% of the time and 1 50% of the times. And there's no way of telling whether it's going to be 1 or 0. But if you do it 1 million times, you will get 500,000 1, 500,000 0. So it's crazy. And Einstein didn't like this because he didn't like the fact that the universe is probabilistic rather than what he thought, which is deterministic. I.e., if I pick up a ball and I throw it and I know all the factors, how heavy the ball is, how high I throw it, what the gravitational pull is, what the mass of the object, the air pressure, we can determine what will happen. And Einstein said, he famously said, God doesn't roll dice. So he just could not believe that a universe could be probabilistic. I have 5 minutes 46 left. And then we have now, this is the crazy one, the many worlds interpretation. I say it's the crazy one, but really it's just as crazy or just as reasonable, depending on which way you want to look at it, as the Copenhagen. The good thing that Einstein would have liked is that it's deterministic. What the many worlds says is that you are merely a part of you're a quantum object. And all quantum objects, when they get involved with the wave function, they become a new quantum object, if you like. And even though this doesn't extend to the macroscopic, what happens is you set up, when you do a measurement, you have a determined outcome. 1 and 0 both come out, but in different timelines. So it's deterministic in as much as if you look at the entire whole picture. Every time there is a measurement, there's a new quantum entanglement that takes place, because we are a quantum object. Of course, what this means is that when you think about the collapsing of the wave function happens absolutely constantly throughout time, it means there's a world where, the Nazis won World War II and 9/11 didn't happen and that type of thing. And it makes one think, how could there possibly be that many worlds? But it really does make as much sense as bores the Copenhagen. It really does. In some ways, it makes more, because it's saying that the universe is deterministic. There are just these billions upon billions upon billions of timelines or worlds where the wave function has collapsed in different ways. 3 minutes, 6 seconds left. Okay, and then we have from De Broglie and Bohm, two very famous quantum physicists, again around about the 1930s. And they came up with a contrasting interpretation to the Copenhagen in many worlds. And what they're sort of saying is that there's a wave function, what they call the pilot wave, that guides the interpretation. So it treats the waves as if it were a real wave and not a probability wave. In the interpretation, it's a real physical wave which pushes the particle around physically. The particle and the wave are both discrete physical entities. And this is what sets it apart from other interpretations. And it is, again, deterministic. Because if you know the strength of the pilot wave, you can work out where it will collapse. So there's no uncertainty principle involved. Again, if we know the exact starting point of the particle, we could, if we knew everything, calculate the exact place the particle would be throughout its path, monitored by the Schrödinger equation, which governs the wave function over time. And there's a guiding wave equation that works in with the Schrödinger. So again, a very illogical, if you like, explanation, but they all are, for the reasons I mentioned before. 1 minute and 11 seconds. And then we have a more modern interpretation. This has come out from about the 1970s. And it's to do with Bayesian probability, which is a very well-known classical definition of probability. And again, the best way to describe it is if you roll a fair die, the chances of rolling a 6 are 1 in 6, because there's one occasion at 6, and there are 6 possible occasions, states that it could be. But a Bayesian world is that it learns from the previous rolls. So if it kept on being 6, it would say, hold on a minute, maybe the die's fixed, biased, or whatever, but we think there's a bigger chance of it being a 6. And so if so you're constantly updating your opinion. And I've only got 5 seconds left. Every time we form an observation, Oh, there goes the clock. We're updating our personal belief as to the outcome of all future observations. So it's not a mysterious event because it's all predicated on our personal beliefs. So we all have different worlds, if you like. Wow, thank you very much. I mean, I probably confused the situation with those interpretations, but it shows you how weird quantum physics is, that they are the best interpretations that we can come up with. Stay tuned for lesson 4. That'll be coming in a few days. And that's just basic linear algebra. The linear algebra that you need to know to be able to understand quantum computing. Thank you very much.